In our everyday lives, time seems constant. As 1 second passes for you, so does 1 second pass for everyone else. But is time really constant? Let's begin our journey by understanding the relationship between space and time through Einstein's theory of special relativity. Special relativity assumes two postulates. First, the laws of physics behave the same in all inertial frames of reference. The second postulate says that the speed of light in a vacuum is always constant. But how do these two postulates explain how space and time are related? Let's look at an example. Let d be the distance light travels in 1 second, which is about 300 million meters. Bob is in a spaceship traveling at a constant velocity of about half the speed of light, and Joe is standing stationary on Earth. Bob has a machine that shoots a photon of light into a box, d meters long. When Bob looks at his machine, he observes the photon travels d meters inside the box. However, Joe, using a telescope, observes the photon travel more than d meters inside the box. But if we know both men must measure the speed of light equally due to the second postulate, how is this possible? Since the laws of physics are the same in all inertial reference frames, we can apply the same equations to both. By using the equation speed equals distance over time, we can see that if Joe observed the light travel a greater distance, he must have also observed the light take more time to travel there than Bob did. So, as 1 second passes for Bob, more than 1 second passes for Joe, and therefore time will go slower for Bob than it does for Joe. Now, by virtue of this experiment, we can conclude that the faster you travel, the slower you experience time, which leads to the overarching conclusion that space and time are not two separate entities, but rather are combined into one larger continuum, cleverly referred to today as SpaceTime. To get a better understanding, let's visualize what space-time looks like. Imagine space-time as a loaf of bread. Now each infinitesimally small slice represents one moment in time, and within each slice is the entirety of the 3D universe. The start of the loaf represents the Big Bang some 13.7 billion years ago, and the end represents some future point at which the universe ends. Based on the equation for time dilation, when you travel at 86% the speed of light, you experience time twice as slow as someone on Earth. As 1 moment passes for you, 2 have passed for someone on Earth. Effectively, this means that your perspective of space-time has shrinked, and the size of your loaf of bread is exactly half of what it is for someone on Earth. As you continue to move faster, space-time shrinks accordingly. But eventually, when you reach the speed of light, you no longer have a loaf of bread, but rather you have one slice or moment. There's no longer a sense of time.